All right. Welcome to section 1.3. We're going to be talking about putting numbers on nature. All right. So first thing we need to do is set up a coordinate system. Our coordinate system for right now is just going to be in one dimension. So we're talking about X. Here we've got the two different objects, a cow and an automobile. The cow's position is +4. Okay, so it's over here on the x-axis at +4. The cow's that was the car's position. The cow's at -5. Those two things have unique coordinate system, and it's on our axis. We only have the x-axis in this one because we're starting with linear motion. But let's talk about some of the things when you see it diagram here. So X is what axis it is. We're going to have two-dimensional motion later, so there'll be X and Y, and then meters is the units. Okay, most of the time will be in meters. Okay, so if they start at 0, they start at the origin, and they start accelerating or running, they're moving in the positive X direction. Okay, so our runner is moving in the positive direction here. We can make a stop motion diagram. Okay, so that means that we record their position at different time intervals. In this case, it's every 1 second we record their position. It doesn't matter what it is because remember we're using a model. And so here we can see every second they move an equal distance here. Okay, so we need a time and a position. Okay, so if this is along the x-axis, then we can see that their position, and here the dots are getting closer, and so the object is slowing down. Okay, if we have a change in position, that's a displacement. All right, and so here, if we start if initially at x equals 50 and we end up our final position at 150 feet, okay, then our total displacement is x of f minus xi. Okay, so we take our final position and we subtract our initial position. That gives us the total displacement of our thing. Okay, so let's go back over here to Charizard, and let's do a little example here. Okay, so we're traveling in one dimension. Let's say here we're going to switch it up a little bit. We're going to go along Y. Okay, so Charizard starts at the origin here, and let's say these are increments of 10 meters. So he's going to move up here to 20 meters, right? This is my coordinate system. It's still one dimension, so it's not a big deal. Okay, but it doesn't matter what direction we're pointing here. Okay, so he's going to jump up in the air. He's going to jump up 40 meters. Okay, so his initial displacement is going to be right here, but then he's going to fall off a cliff, and so he's going to go minus 10 meters, minus 20 meters, and minus 30 meters, minus 40 meters, okay, and 50 meters. Okay, so if Charizard starts off here, our initial position, and we'll say xi is going to equal 40 meters. That's our initial position. Let's say he falls off this cliff. Oh, he goes down here, okay? Our final position, x final, is minus 50 meters. Okay, so what's our displacement for this? Okay, our total displacement, we're going to say delta x is going to equal x of f minus xi. Okay, and this is really important because we're going to get a negative sign here, and that tells us about the direction. So don't forget about the negative sign. So I'll put my numbers in here. My final position is minus 50 meters, and my initial position was 40 meters positive, but it's minus 40. Okay, So now I can see that Charizard underwent a displacement of 90 meters. Okay, so he started up here. Charizard started up there, and then he had a displacement vector that looked like that. And his displacement vector, delta x, is minus 90 meters. So it's pointing down. Maybe Charizard's a girl, I don't know. It doesn't matter. Okay, so let's look at this example. All right, so we started at xi, we moved to xf, so we had a displacement of 100 meters. Okay. In order to quantify motion, we'll need to consider changes in time. All right, so it looks like here we got a picture. We're moving at 20 feet every second. Okay. 20 feet every second. And our time interval delta t is 1 second, right? But we could find the time interval between two different positions, right? So if we started at, say, 40 meters and we went to 120 meters, it would take us 4 seconds to get there. So that's our time interval. That's delta t. All right, let's look at a problem here. Emily is enjoying a bicycle ride in the country. Okay, she's enjoying a bicycle ride. I like the bicycle. And uh and let's see, what does she do? Now, when you do the problems, you should read the problems very carefully. And oh, look who's here. Pikachu. I have one and realize I'm gonna put Pikachu over there. Yeah, he's gonna be next to my stormtrooper. These are not mine, they're my son's, okay? Because he's a teenager now. He used to have all these cool toys, but he doesn't play with them anymore. I'm like, those toys are cool. But now Pikachu is gonna help me teach physics along with my plant George. Okay, so Emily is 3 miles east of the water tower. Okay. A half hour later, she's 2 miles west of the water tower. What is her displacement during this time? Okay. I feel like this is, we're getting ready for velocity, but we're just going to figure out what her displacement is. Well, let's draw a picture. Okay. Yeah. Why would we not draw a picture? Always draw a picture. Okay. And I'm going to get, yeah. Dinosaur. No, this is Squirtle, isn't it? I don't think it's no. Damn, Pokemon. Yeah, Bulbasaur. Okay. So he starts at a water tower here. What does it say? Okay, so he start Bulbasaur. No, it's Squirtle. What am I talking about? Oh man. All right. So they start 3 miles east of the water tower. 3 miles east. Okay. And no, that way's west. What does Okay, so this way is east and this way is west. And so they start 3 miles east of the water tower and we end up 2 miles west of the water tower. Okay, so we start off over here. I had to look it up. It is Bulbasaur. Oh my gosh. What the heck? Okay. So Bulbasaur starts at where's Bulbasaur start at? Bulbasaur starts 3 miles east of the water tower, and Bulbasaur travels 2 miles west of the water tower. Okay, so we go like this. So Bulbasaur goes, okay. In what is the displacement during that half hour? That took 30 minutes, right? 30 minutes. What is the displacement during that time? Well, we start off here at 3 miles. We went back to the center, and so that was 5 miles in 30 minutes. Okay, so that was our displacement. Our displacement was 5 miles. Okay, that wasn't too bad of a problem. All right, was that all that it's asking for? Yeah, so here's our water tower. We drew the picture and we subtracted the final position from our initial position. Okay. Oh, that's good. They use the negative signs there. Okay, so they're saying the final position west is negative. Yeah, that's good. Okay, let's do that. Yeah, so in my drawing here, this is minus 2 miles. And so, yes, our displacement here is going to be our x of f minus xi. And then, of course, this is minus 2 miles minus 3 miles. And so our displacement is minus 5 miles. Or we could say the displacement is 5 miles to the west. All right, we did that one. Okay, that was good. All right, we're getting the hang of this. Maria's at a position of x equals 23 meters. Okay, so she's at positive 23 meters and she undergoes a displacement of minus 50 meters. What is her final position? So you basically take 23 meters. That's her yeah. So let's let's do this one. Okay, so her x of I is 23 meters. Okay, we can use our equation to solve this one. And the equation is delta x equals x of f minus xi. We're just going to plug in the numbers here and that'll give us x of f. Okay, and it tells us in the problem that our displacement is minus 50 meters. Okay, so now we just have to solve for x of f. So this one's not too bad. So we're going to get delta x on the other side. So we will have x of f, that's what we want to end up with, her final position. We're going to put x of I on the other side. Okay. So, yes, we'll get it on the other side. So it's going to be delta x and then plus x of I. Yeah, that works out. Okay. So it'll be minus 50 meters plus 23. That's not meters, that's miles. Okay. And that, oh, that should be, yeah, that's minus. Okay, so we have minus 50 plus 23. That is gonna give us minus 27 miles. And so x of f equals minus 27 miles. Okay, let's go back and look at the answer. All right, so we think the answer is A. We got minus 27 miles, and indeed it is minus 27 miles. Okay. Let's do another problem. An ant zigzags back and forth on the picnic table as shown. All right, the ant's distance traveled and displacement are. So distance traveled is a little bit different than displacement because the distance traveled is how far did he actually walk altogether. So if you just measured every step along the way, uh, then you would get the total distance. Like if you're walking, right? If you walk back and forth, on your phone and you're keeping track of the distance, that hopefully is going to tell you how far did you walk. But displacement is how far did you end up from where you started. All right. So let's look at this. And I think it starts off at 40 here. Okay. And so the displacement then, it looks like he's going to go from straw picture. No, dang it. Okay. Well, I ruined it, but oh well. Let's look at this. Let's start with the displacement, okay? So definitely he starts off at 40, he ends up at minus 10, okay? And so right there, that tells us that his net displacement's minus 30. So it can really only be E, but let's talk about the distance that he traveled, okay? Because it looks like he went all the way over here from 40 to what is that? 15. Okay, so 40 to 15. So what is that? That's 25. Okay, then he came back 15. So he went I'm a little confused by I'm always confused by this. I forget this one. So the distance traveled, right? He went from 40 over here to 15. That's 35. He came back from 15 to 30. That's 50. Okay. And then he went this straight part here. So that should be That should be 70. Well, I'm not sure what I think about that. It appears to be wrong. Well, the displacement is definitely minus 30. And so this part's 20, I guess, and that part's 15. And oh no, this part's okay, I get it. So I guess this part maybe this I don't know. That doesn't I don't like this picture. Uh the only answer can be is minus 30 because it started at 40, it ends up at 10, so you move to minus 30. And then we would measure the distance here. So this goes from 10 to 30, that's 20, and then it looks like this blue part here is also maybe 20, and then this part is 10, so that gives us 50. Okay. Not a great picture, but whatever. All right. That is the end of section 1.3. So watch section 1.4 after that.